Today, in this Mathematica tutorial, we are going to talk about integration by substitution. So I'm going to do these three problems right here in Mathematica, but I'm going to show you how to calculate those by hand also. Okay, let's get started. Now, we'll make me smaller, get me out of the way. All right, let's focus first on this first problem, which is the integral of a polynomial. Now this is one of the most simple kinds of integrals you can do, but if you're new to this, it's important to learn. Okay, so I've got a Mathematica notebook opened up. First of all, I want to show you how easy it is to use Mathematica's built-in function integrate. So I'll write integrate, and then I'll write the function x cubed plus 3x. I've left a space between the 3 and the x. You can put an asterisk if you like, and then I'll say to integrate with respect to x. Okay, shift enter. That takes a little while the first time because I had quit the kernel earlier, so normally it's not this slow. All right, here is our answer, and then I'll just show you that we can do it again and it'll go faster. Okay, basically instantaneous the second time. All right, so the integral is x to the power of 4 over 4 plus 3 halves x squared. All right, now it does not include the plus c. Okay, so just to show you that the derivative of this is actually x cubed plus 3x, let's differentiate. All right, so we have d, and then we'll say with respect to x. So this is the first derivative of this with respect to x. Okay, now you can see the answer, x cubed plus 3x, which is exactly what is inside here. So when we are taking the integral, otherwise known as the antiderivative of a function, we are seeking a function such that if we differentiate this new function, we get what is exactly inside what would be in the thing to integrate. Okay, now also notice that if we would add here plus 5 and differentiate that, we would also get x cubed plus 3x, and that is because the derivative of 5 with respect to x is 0. Okay, so what is missing when you try to integrate this in Mathematica is the plus c. Okay, so let's just note that let's write in comment form, integral of this with respect to x, WRT x, is this plus c. All right, because you need to be as general as possible when you don't have a definite integral. This is known as an indefinite integral. Okay, where c is any constant. All right, so now let's talk about how you would integrate a polynomial by hand. All right, so what you do is you add 1 to this exponent. All right, so 3 plus 1 is 4. And at the same time, you divide by that new number that you got. Okay, so I would have to put 1 over the exponent plus 1 multiplied by x to the power of n plus 1, where n is this exponent, in our case 3. Right, now likewise with this one, this exponent, the exponent of x is just 1, and so if we add 1 to 1 we get 2, and so we have to then divide by 2. So the integral of 3x is 3 halves x to the power of 2. All right, putting those two together give us x to the 4th plus 3 halves x squared, and then you should not avoid the plus c. Okay, you always need to put the plus c in. So that's how to integrate a polynomial. Now, of course, integrals get more complicated, and you should practice plenty of integrals of polynomials before you move on. But I am going to move on and talk about integration by substitution. Okay, so I'll open up a new cell and we can now talk about this process. Okay, so now let's open up palette, because I think there's a nice symbol that I can use in the palette. So basic math assistant, and then a palette appears, and I'll move it over here so we can see it. All right, so there's a symbol down here at the bottom, which you can't see because of the resolution, but I'll just click on it, and there appears the symbol that I'm after. Okay, I'll close this, and now this gives me an opportunity to enter something inside this box, and I'll put x cubed and then cos x to the 4th plus 2, and we want to integrate that with respect to x. All right, now if I press shift and enter, it'll give me the answer. So, and that of course works in Wolfram Alpha 2, which is a phone app. Here's my mobile phone. I've got Wolfram Alpha on this as well, and I think it cost me about $2.50 or so. It's not very expensive, and it's also good for doing this kind of thing while you're, you know, out away from the computer, sitting on a beach or whatever, or out and about at your university. Okay, but we are talking about integrating this by hand, and so we do this by substitution. Now, let's first observe that the derivative of x to the 4th plus 2 is 4 times x cubed. Okay, so now this is all going to be one big comment. Okay, so, but I won't put the comment in as in the bracket and asterisk until after I'm done talking about this, because I don't want it to all turn turquoise just yet. Okay, so I'm going to note that d on dx in Leibniz's notation of x to the 4th plus 2 is equal to 4x cubed. Right, that's the observation. Now, what I'm noticing here is that this x cubed is matching this x cubed here. Okay, so what I want to say is that this x cubed over here is a derivative. All right, so let's write down. Now, I wanted to say since this is true, comma, we have, I'll copy this. Okay, we have this equal to, now this is not quite the derivative of this one. What would I have to do to make that so? All right, so if I put this in right there, so if I differentiate this, I get 4x cubed, right? So if I want to make that a true statement, I need to put in front 1/4. All right, because now when I differentiate x to the 4th plus 2, the 4 comes down and it will cancel with this 1/4. Okay, and that will indeed be x cubed. All right, so that's good. All right, now that we have that, all right, this notation here is not ideal, so let's open up the palette again, and I'll enter a fraction just so it looks better for us. All right, let me find the fraction. Okay, so d on dx. Now, you have to be really careful because these are not fractions. This says take the derivative of something with respect to x. But in order to remember the rules of how calculus and differentiation and integration work, these symbols are convenient. All right, because they help you remember the rules of integration, differentiation, so on, because they often work the way fractions do, right, as in cancellation. Okay, now look, if these were fractions, I would be able to cancel the dx with this dx, right? They're not fractions, but this helps us remember integration by substitution. Okay, so let's go down here and include a new line. Right, so here we've observed that that x cubed can be written as a derivative. Okay, our next observation is that if we go and introduce a new letter, let's say U, all right, and I'll do that right here and right here, because if I say U is equal to x to the fourth plus 2, well then this is true, isn't it? Okay, comma, where U is equal to x to the fourth plus 2. All right. Now Mathematica wanted to tell me something, but I'm not intending to execute this as a calculation. I'm just typing to talk to you about it. Okay, so right now let's consider the substitution part of this. Okay, so we've said U equals x to the fourth plus 2. All right, we've replaced that U there and there. Now, since we're using Leibniz's notation, it reminds us that this is actually equal to, because I'm thinking if these were fractions, I would cancel a dx, right? And that reminds me of the rules of integration. Essentially, that this is the integral of cos u with respect to u. Okay, and this is the substitution. All right, now this integral has become very easy because the integral of cos is sine. All right, remember, differentiate sine and you get cos. So the integral of cos is sine. Okay, now we can come down to the next line and simplify that. And say that this is just sine of u. Okay, now that we have that, don't forget the plus c. So plus c. Okay, and now we'll include another line because next we want to go and replace x to the fourth plus 2 where the u is. And so I'll copy this, put it right here. Now I can get rid of that. And this is the answer. Okay, so the answer is 1/4 sine of x to the fourth plus 2, and then all plus c. All right, now that we've done this by hand, the integral by substitution, let's go and put a comment around all of this. So bracket, asterisk, and you see it all turns turquoise, and then asterisk bracket. Okay, I'll make this bigger. All right, now I'll copy this out and actually press Shift Enter. Copy, paste. Okay, now we're going to calculate this integral. All right, now Mathematica says that it is 1/4 sine of 2 plus x to the fourth, but it doesn't include the plus c. All right, now you should note that the plus c should go in there. All right, so we've calculated this in 2 ways. All right, and that is the second question. Let's now do the next one. Now, in this one, we've got a fraction. So 1 on 5x minus 3 all squared is to be integrated. But what we have different in this is a 1 and a 2 there. Right, now this is a definite integral. This means that we should evaluate this within a given region and take a difference, okay? But you'll see in a moment. First of all, because we are calculating a definite integral, we can also interpret this in another way. All right, so I'm going to plot the function 1 on 5x minus 3 all squared, and let's choose a range to plot it in. X going from 1 to 2. All right, let's see, Shift Enter. All right, now we see a curve. Okay, so when you are calculating an integral and you're given a number at the bottom and a number at the top, well, you can interpret that as an area under the curve, okay, provided that you've got a nice function, and what I mean by that is it's smooth and continuous, then you can interpret it as the area under a curve. Okay, so the area under this curve from 1 to 2 is given by the integral of this from 1 to 2. All right, but what does that mean? Let's calculate it. So in order to calculate this, we should first do an integral by substitution. Okay, so I want to copy. Actually, you know what? I don't have the top and bottom. So let's open up the palette again. And I'll show you the button I'm clicking. This one right here. Okay, now I'll close the palette again. All right, so I want to integrate this function. So I'll paste that in there with respect to x from 1 to 2. All right, now if I press Shift Enter, I'll get a number. So let's just do it. Shift Enter, 1 over 14. But how do you calculate that by hand? Okay, so I'll show you. What we want to do is, since this is an integral by substitution, we want to make an observation about what we can substitute. Okay, so I'll copy this, Control C, Control V, and I'll say, well, look, in the numerator, you can associate that number 1 with a derivative. All right, so what if we are to say that this is something like the derivative of 5x minus 3 with respect to x. All right, now what happens if we do this? You think about, what is the derivative of 5x minus 3 with respect to x? Well, it's 5, right? 5x minus 3 is a polynomial, and if we were to differentiate that with respect to x, we get 5. So in order to make this true, we are missing a 1/5, so that will cancel with the 5 that we get when we differentiate. Okay, so now this is a true statement. And once we have that, we can decide on a substitution. All right, so we'll say let u equal 5x minus 3. Okay, so then I would be able to replace this with a u, and down here as well, 5x minus 3 equals u, and then I'll have to say where u is equal to 5x minus 3. Okay, yes, now the next thing we want to do is observe that if this was a fraction, then we would be able to cancel a dx. Okay, so, but they're of course not fractions, it just helps us remember the rules. Now, applying that would mean that I then have a du there, I get rid of this dx, and I have a 1 there. Okay, so now that helped remember the rules. Now we have a 1 on u squared, but we want to represent that as u to the power of minus 2. Okay, so let's do that. U to the power of minus 2. Okay, and that's something that is very easy to integrate. Okay, all you have to do is add 1 to the exponent and divide by the new exponent. So let's go down into a new line. All right, now I'm about to integrate this, so I need to get rid of the integral sign, because once I integrate that, well, it's then integrated, and then I need to evaluate it between the point 1 and 2. All right, so we are first of all integrating this, so add 1. If I add 1 to minus 2, I have minus 1. And then I need to divide by the same minus 1. Okay, 1 divided by minus 1 is minus 1. And then over here on the right, once we've performed the integral and we want to evaluate between 1 and 2, well, you'd usually draw a square bracket around that. All right, let's see if I can find the appropriate notation in the palettes. Palettes, Basic Math Assistant, and I'll just have a look and see what we see. Well, I don't see it. I don't see what I want there, so I'll click Advanced. I don't really see what I need in the advanced area either, so I'll just choose one of the notations that I see. All right, and then I'll just improvise. Okay, so normally what we do is we either put a square bracket around, square bracket, and then on the right we put the number, the bottom number and the top number to indicate what we're doing, all right, once we have integrated. But you can sometimes abbreviate that with a bar on the right. Okay, so let's say from 1 to 2. Okay, something like that. All right, now this is really bad because I didn't have the option to write this, to type this out properly. Okay, but this is sort of the best I can do from within this window. Okay, so now that we have that, let's do some simplifying. Okay, so I'll copy this, paste. Now that -1 that's there, let's just put it out in front. Okay, and I can get rid of it. Okay, and next thing we need to do is replace this u with 5x minus 3. Okay, now we can remove that. Okay, now that we've got that, let's copy this and come down to a new line. All right, now what does this mean? This means that we substitute in 2 into this function right here, and we subtract what would happen if we substituted in 1. Okay, so now I'll get rid of this. I'll replace the x with a 2, so I'll say times 2 times 2. Okay, and then I have to copy this, subtract what happens when I substitute in 1. All right, now there's just a numerical calculation to do. We just have a difference of 2 quantities. Okay, so let's just calculate one of these, and I'll get Mathematica to do this calculation. Okay, so notice I put in a new cell, so I don't have to execute any of this that's here. If you did, you'd probably get an error message. Okay, so I've come into a new cell, and I'm going to press Shift and Enter, and I have -1/35. Okay, so let's copy that and come down here to a new line. So we have -1/35. Now I want to subtract this other number. Okay, so come down here and find out what that number is. It's 1/10. Okay, now there's a minus there, right? But the result of that is plus, so it gives us plus 1/10. Okay, now we copy this, simplify that. What is that? It's 1/14. Okay, so 1/14. Now remember what we did when we calculated this using Mathematica first of all. Okay, so I'll do that again, Shift Enter, 1/14. Okay, down here, when we did all this by hand, we got 1/14. So these agree. All right, that's great, because that means that we probably did the calculation correctly. Okay, so I hope you learned how to calculate an integral by substitution and how to get Mathematica to check your results. And that's all I have for you for now, and so I'll see you next time. Thanks for watching. Bye for now.